Welcome back to the second part of the control rig tutorial. And today we're going to talk about IK controls, IAM system and all the backward solve. Let's go! So we left Mr. Dewey's with all FK controls on spot. If we take a look at the graph, in first place we built a simple logic system. Before moving to a simplification system using variables and arrays that we defined once via construction event. Now we're going to build IK controls. For that, we'll do the same process as we did with FK controls. We first create a null, right-click, new null, we can call it IK controls, and this is where we will put all our IK controls in here, but this time we won't pay attention to any specific hierarchy. Let's start with the left arm here. When you create an IK control system, you need two controls. One IK control and one pole vector. Let's build the first one and I explain the other one right after. For the IK control, we're going to create like a handle with same process as we did on the first part. Here, create a control from L_hand002. Right-click and unparent. Place it in the IK controls. Let's give it a box thick shape and scale it to something like 0.06. I go here with a dark gray color, and don't forget to correctly rename your control. For example here, by adding IK in it. So we just created the first part of the IK control system of the left arm. This control will be the one that will drag around in order to move and bring the following bonds that we will determine afterwards, just like a chain. To fully build this system, we need what I've just talked about, a pole vector. This will be the direction we specify to our IK system to prevent Mr. Dewey's elbow from bending in the wrong direction. It can also be controlled afterwards. You'll see. There's no magic trick to creating pole vector. It is the same process as creating regular control. Here, as I mentioned, the pole vector will help us determine the right direction where Mr. Dewey's will bend his elbow. That's why we are going to start from the L_arm002 bone. Right-click and create new control. Unparent and place this new control in the IK controls now. No need to further parent our IK control here, like I said. Rename it with PV for pole vector. Give it the same color for IK as we did for the handle. Here I picked a sphere thick shape, rescale it to something like 0.05, and pay attention here, because we need to move the actual control and not the shape. Focus on transform while I drag the control. We move the control itself, not its shape. And now we need to bake its position by right-clicking on the control and select Set Offset Transform from Current. Now the control is baked with this new position, and even if you compile, it's staying at the correct position. Okay, now we have fully visually built our IK system of Mr. Dewey's left arm, with one handle and one pole vector. Let's do the same with his left leg. Select here the L_foot001 bone and repeat always the same process. Here we are creating the handle. Then select the L_leg002 bone corresponding to his knee and create again a bone. This will be our pole vector, which will help to set good direction when Mr. Dewey's will bend his knee. I keep the same color and shape as the arm. Offset the control itself and bake it via Set Offset Transform from Current. Great! Now we just have to do the same thing with his right side. We can redo the operation by hand or use mirror function as we did in the first part of the tutorial. There's a lot to cover when mirroring. I invite you to take a look at the first part of this tutorial to understand the whole process. Once you created the other side, let's jump into the graph. We are going to build the system in an empty space for the moment. First, go with basic IK. This node will build all the logic for a 3 chains IK system. We will determine item A, B, the effector and its space, primary and secondary axes, and the pole vector. Let's specify everything. We are going to start from L_arm001 to L_hand001. Item A will be L_arm001. Item B is L_arm002. Effector item is L_hand001 bone. Now for the effector, you need to drag and get control of the L_hand001_IK control. Next, we need to specify primary and secondary axes. Quite simple, primary axis is the axis where item A is going toward the effector. Here the y-axis. Secondary axis is the axis where item B is pointing toward the pole vector. So in final, item A is pointing towards the effector on -y, and item B is pointing toward the pole vector on -z. Let's just write it in our node. Next, let's drag and drop our L_arm pole vector in get control mode. As you can see, we cannot directly plug its transform. We need to unfold this output and get the translation only. For the moment, let's disconnect the FK controls in order to test our IK system. And it's perfectly working, as well as our pole vector. Let's do the same for the right side. A fairly simple method because you can directly mirror everything in the graph. Duplicate all the left arm system here. Right-click and select Search and Replace /mirror. Same as for our controls. We are mirroring on X-axis with no axis to flip, and we are looking for L_ to replace with R_. No need to bother with axis here, they are in the right direction. Just connect the execution pin and let's verify. Both left and right arm are working. Now we can do the exact same things for his legs. Great! All our IK system is working. But now we are facing the problem of combining both IK and FK. We cannot simply connect both one after the other. This is why we need to build what we call a FK-IK switch. Let's go back to our viewports. Collapse the hierarchy here and let's create a null to organize things a little bit. Right-click in an empty space and create a new, name it switch_control. Let's rescale it a little bit and then drag it out of its original position. Remember that we are creating an actual offset here. I'm going to change its color as well and rescale it a bit once again. Now remember, as we made a modification on its real transform, we need to bake its new position. Right-click and select Offset Transform from Current. To make it a real switch, let's change its value type in its Details panel. Change it to float. By default, the primary axis is X, as you can see here. That's fine, we can leave it as it is. You can see the debug line telling you the mean and max of your float value here. Shift-click on mean and max in the value heading, and if you drag your control, you have now a switch. You can adjust the max value if you wish to make it shorter. Now, let's make some nodal code. What we are going to do here is to specify two ways, just like a Boolean value. This is why we are going to use a branch node. Right-click, select branch. The condition of this branch depends on the float switch control. Just click and drag this latter and choose get control. Here the logic is to remap our float value to make it like a real switch, allowing low tolerance to avoid sliding a bit too long on our switch when we want to alternate between FK and IK. So let's get a remap node, connect the value, min and max inputs outputs. From its output result, get a is nearly equal node that you plug into the A input. For the tolerance, add a value like 0.1. Now connect the ball results to the condition of the branch. Next step is to make visible both controls of Fk and Ik at the correct time. By default, let's say we want to see the Fk controls, and when we drag our switch, Ik controls will appear and then Fk will disappear. The way to do this is simple. We need the hide controls function. Right-click, select it. This will help us determine which controls are visible. As you can see, we have to specify arrays. For this one, let's get the Fk control variable by dragging variable here. Connect everything and leave it as active as we want it to be visible in the first place. Repeat the same operation just after, and here we need to create the variable for our Ik controls. Same operation as we did in the first part of this tutorial. Create the variable and specify its logic once in the construction event part. Now, let's get the Ik controls variable and plug it to the array of the second hide controls function with the active ball option deactivated. Connect the execution pin, and now let's do the same with the Ik controls. Just repeat the same operation using hide controls function. Just duplicate all these parts, but this time inverse the ball options. Connect it with the following Ik systems. Now we have two specific ways where we can alternate both Ik and Fk control. An additional tip for giving your character more control is to add a naming node for his head. Let's first create a control. Choose a bone that represents the most your head's character. Here I go with the spine 004 bone. Kind of the same logic as our pole vector we created in the first place. Unparent it and let's rename it head_am_control. Rescale it and shape it as you wish. Here we are going to offset the control and bake its new position as always. Let's organize our tree structure here. We could place it into another null, but I leave it simple here. Let's pick a fun shape. Why not the arrow for thick? Adjust another time with scale, and voila! Our control is in spot, and now we are going to define its logic in our graph. We are going to create code right after our Fk controls. Let's pick the am function here. Pretty simple. For the item, we have to pick the bone we chose for our control just before. The target will be the head IM control in get control mode. We have to unfold the transform pin in order to connect only its translation. Same as for our Ik system, we then need to determine axes, both primary and secondary. Primary refers to which axis the bone is pointing toward, and secondary where the bone is pointing for the following hierarchy of the bone structure. Here we have Z positive on primary and Y positive on secondary. Connect and let's check the result. That's all good for Mr. Degrees. Final step of this tutorial, as we mentioned it on the first part, we have to specify the backward solve event in order to easily bake animation in our sequencer afterwards and add additive layers. Like so, you have a complete control rig. And this step is pretty simple, as we're going to do the same logic as our first part of our forward solve event, but with some inversion. Let's jump into it. Just go back to the Fk controls nodal system and copy paste it. From there, just invert the two variables, because we want to retrieve our controls from our bones in the first place. It's quite the opposite of the forward solve event. Now, one way to see if everything's in order is to go back to our viewport and look at the top left of the UI. Here you can toggle between different solve modes. For example, if you choose construction events, you will be able to move around bones directly. Forward solve is the default event mode we were working on since the beginning, and then we have the backward solve. If the code you put in place in your graph is wrong, by switching to this mode, your character will go crazy. And here we are good to go. We can also verify it when we will try to bake controls in your sequencer. I'll do a video about it soon, don't worry guys. So here we are, a full operational control rig for our Mr. DBs, with the 3 main events, build and on point. Now you know how to build an entire control rig on a simple bytecode character. And that's it guys, you were a lot asking for this kind of tutorial, because I know that control rig is not easy, so I hope you understand everything, and see you on next Thursday for a new tutorial. Of course, if you like this video, don't forget to subscribe. Thanks. Bye.